Dear students, very good afternoon. Today we are going to discuss about how to find eigenvalue and eigenvector for the non-symmetry matrix. So for non-symmetry matrix, we are going to take A as the following matrix. So for non-symmetry, what is non-symmetry? When A not equal to A transpose. When A not equal to A transpose, it is called as non-symmetric. Then what is a symmetric? Symmetric matrix means the matrix which satisfies the condition A equal to A transpose. So here for non-symmetry, A not equal to A transpose. Okay, so it is non-symmetric. So here we are taking a very particular case. So that is our eigenvalues will be repeated. Our eigenvalues will be repeated. So we are going to discuss such a problem. Here going to discuss a problem for which the eigenvalues are repeated. Okay, eigenvalues are repeated. So for this particular case, we have to take an example matrix. So for the matrix A, we have to find eigenvalues and eigenvectors. The problem here is A equal to 6, then minus 6, and then 5, and then 5, after that 14, minus 13, and 10, and after that 7, then minus 6, and then 4. Okay, this is matrix A. So what is A transpose? So A transpose, it is not necessary to find A transpose, because you can compare here itself. Here this element is 14, this element is minus 6. These two elements are not same. That is A12 is not equal to A21, and A31 is not equal to A13. So this is definitely not going to be a transpose matrix which is equal to the original matrix. So it can be a transpose matrix, but it cannot be equal to original matrix. So here A transpose will not be equal to original matrix. So 6, 14, and then 7, here minus 6, minus 13, and then minus 6, and then after 5, and then 10, and then 4. So this is A transpose. So which implies A not equal to A transpose. A not equal to A transpose. So what is this? This is a non-symmetry matrix. This is non-symmetry matrix. Okay. Okay, now we have to find eigenvalues. So to find eigenvalue, we have to find characteristic equation first. We have to find characteristic equation. So how can you write characteristic equation for a 3 by 3 matrix? So for 3 by 3 matrix, we will have lambda cube minus s1 lambda square and plus s2 lambda minus s3 equal to 0. Okay, so we have to substitute values for s1, s2 and s3. So s1 is nothing but trace of matrix A. Trace means sum of the main diagonal elements. So that is 6 minus 13 then plus 4. So that is equal to minus 3. And what is our s2? s2 is given by, so s2 can be written as sum of minus of main diagonal elements. So that is for 6 the minus are minus 13 then 10 and minus 6 and after that 4. And for this minus 13 we will have 6 then 5 after that 7 and then 4 plus then we will have for 4 we will have 6 then minus 6 and 14 and minus 13. Okay, so our s2 value will be so we will get minus 13 into 4 is minus 52 plus 60. So minus 52 plus 60 is 8 and then plus here we are having 6 4s are 24 minus 35. So 24 minus 35 is nothing but minus 11. Okay, and after that here we are having so 6 into minus 13. So 6 into minus 13 is minus 78. Then 14 into minus 6 is 84. So minus 78 plus 84, that is equal to plus 6. So totally we will have s2 equal to, so 8 plus 6 14, 14 minus 11 is 3. Okay, now we have to find s3. We want to find s3. So s3 equal to determinant of A. So what is our A? So determinant of 6 then minus 6 and then 5. 6 minus 6 5 and after that 14 then minus 13 and after that 10 and then 7, then -6 and 4. So we are all aware of how to find determinant. So 6 into, so -18 into 4. So what is -18 into 4? That is -52. Okay, I shall write answers directly. So we will have 6 into -18 into 4. -18 into 4 is 52. -18 into 4 is 52, and after that 6 into 10 is 60. Here it is -60. So minus of minus is plus 60. 60 minus 52, that is 8. That is 8. 6 into 8, and here already we are having -6. So when we introduce minus symbol, it will become plus 6. So plus 6 into 14 into 4. 14 into 4 is 56. 7 into 10 is 70. Then 56 minus 70 is -14. And now for this 5 into you will have, so 14 into -6 minus 7 into -18. So 14 into -6 is -84. Then 7 into -18, minus of -7 into, so minus of 7 into -18 is plus 91. So 91 minus 84. 91 minus 84 is 7. So 5 into 7. So on the total, on the whole, we will have S3 equal to -1. S3 equal to -1. So now we have found S1, S2 and S3. So here we can substitute. So we will get characteristic equation as lambda cube minus of minus 3 will become plus 3 lambda square, and after that plus S2 lambda. So it is plus 3 lambda and after that minus S3. So it is plus 1. It is plus 1 equal to 0. So you are all familiar of this equation. This is a cube plus 3a square b plus 3ab square plus b cube. Here b equal to 1. So this equation implies a cube plus 3a square b plus 3ab square plus b cube. So this is nothing but lambda plus 1. So lambda plus 1 the whole cube. Lambda plus 1 whole cube equal to 0. Then lambda equal to -1. How many times? 3 times. So lambda 1 so equal to -1 3 times. So after that, so we can write here lambda 1 equal to -1, and again lambda 2 is also equal to -1, and now again lambda 3 equal to -1. So since all the three eigenvalues are equal, that is one eigenvalues repeated 3 times. So this is the example of repeated eigenvalues. Repeated eigenvalues. Okay, so now we have to substitute this lambda value. Where we have to substitute? So this is our eigenvalues. This is our eigenvalues. So we have found our eigenvalue. Okay, this is our eigenvalue. So corresponding to eigenvalue, we will have eigenvectors. We will have eigenvectors. Always eigenvalues are unique. Okay, always eigenvalues are unique. But for a single eigenvalue, of substituting it in an equation, we can have different eigenvectors. Okay, now we want to find eigenvector. Okay, so how to find eigenvector is the important part of this problem, because till this step everyone can do. So from this step onwards we have to do very carefully. So in order to find eigenvector, we are considering A minus lambda I into x equal to 0. This is what our equation. For the as result of this equation, we will have eigenvector. So what is our A? A equals 6 minus 6, 5, this matrix. So we are writing here. So this matrix will, this equation will become, 6 minus lambda, 6 minus lambda, and then minus 6, and after that 5, and after that 14, and after that minus 13 minus lambda, and after that 10, and finally we will have the last row 7, then minus 6 and 4 minus lambda, 4 minus lambda. This is our A minus lambda I into what will be our x? X will be x1, x2 and x3 and x3. That is equal to 0, 0, 0. We will have 3 zeros. We will have 3 zeros. So we have to substitute the lambda value. Since all the 3 lambdas are repeating, one lambda value is repeated for 3 times. So we can substitute only that lambda value. So substitute lambda equal to -1. Substitute substitute lambda equal to -1. So in the above matrix, okay, here we get 6 minus -1 will be 7, and after that it is -6, and after that it is 5. Here we will have 14, and after that -14. Okay, it will become -1. So it is +1. So -13 plus 1 -12. -12, and here also it will, okay, it is on here 10. Here it is again 7, and then -6, and then 4 minus -1, it will be 5. It will be 5 into x1, and then x2, and then x3. So we are having values for lambda now, and we have substituted that value. So now we can write the equations very easily. So how to write the equation? We have to multiply both A minus lambda I matrix, that is this matrix, and this matrix. So now we will have the equation 7x1 minus 6x2 plus 5x3 equal to 0, and after that we will have 14x1 minus 12x2 plus 10x3 equal to 0, and again we are having 7x1 minus 6x2 plus 5x3 equal to 0. So here from these three equations, we can identify that these three equations are equal to one single equation, only one single equation, because these three equations are very identical, they are equal, they are identical. So we can consider only the first equation, so we get 7x1 minus from 1, okay, we are taking this equation from equation 1. So 7x1 minus 6x2 plus 5x3 equal to 0. So this is the only equation that we can take from these three equations because they are all identical. So now we can get three eigenvectors by substituting x1 equal to 0 for the first case. For the second case also we can substitute x2 equal to 0. For the third case also we can substitute x3 equal to 0. x3 equal to 0. So by putting x1 equal to 0 in 1, we get 6x2 equal to 5x3. 5x3. So we will get x2 by x3 equal to 5 by 6. 5 by 6. 5 by 6. So now we get the eigenvector. So we have to write eigenvector by capital letters. So capital X1 equal to x1, x2, x3 are eigenvectors. So x1 equal to 0, x2 equal to 5 and x3 equal to 6. And now when substituting x2 equal to 0, we get 7x1. 7x1 equal to minus 5x3. Minus 5x3. So x1 by x3 equal to x1 by x3 equal to what will we get? x1 by x3 equal to minus 5 by 7. Therefore the second eigenvector x2 equal to minus 5 then 0 and then 7. And now x3 equal to 0. So now to find x3 equal to 0, now to substitute x3 equal to 0, we get 7x1 equal to 7, x1 equal to 6 x2. So 7 by 6 equal to x2 by x1 or x1 by x2 equal to 6 by 7. So here we are having the third eigenvector as x3 equal to 6. So sorry, we are having x1 equal to 6, x2 equal to 7 and x3 equal to 0. So you can substitute these values in the given equation. So 7 into 0 0, then minus 6 into 5 is minus 30, 5 plus 6 is plus 30, minus 8 plus 80 will become 0. So this is correct. And now this, so minus 507, so minus 35, 0 plus 35, it will become 0. So this eigenvector is also correct. Now 6 7 0, 6 7s are 42, then this is minus 6 7s are minus 42, so plus 42 minus 42 plus 0, so it will become 0. So this eigenvector is also 0. So this eigenvector is also correct. So now we are having our final result, eigen value and eigen vector. Eigen vector. Okay, so for lambda 1 equal to minus 1, since it is repeating 3 times, lambda 1 equal to minus 1, we are having, it is repeated 3 times, repeated, okay, repeating, so simply you can write lambda itself. So lambda equal to minus 1, repeating 3 times, repeating. Repeating 3 times, or you can write lambda 1 equal to minus 1, lambda 2 equal to minus 1, lambda 3 equal to minus 1. So for each lambda 1, lambda 2, lambda 3, we will get, for lambda 1 we get x1 equal to 056, 0 5, then 6. For x2 we will have minus 5, 0 7. So for lambda 2 we will have x2, and for lambda 3 we will have x3. So x3 equal to 6 7 0, 6 7 0. Okay, this result should be highlighted. Okay, this is the final result of our non-symmetric matrix possessing repeated eigenvalues. In particular, the eigenvalues, all the eigenvalues are repeated, all the 3 eigenvalues are repeated and equal. Okay, and here we are obtaining the same identical equation. So all the 3 equations are very identical. So we are getting one equation, and for that one equation we have to take x1 0, x2 0 and x3 0, and we have to find the remaining values, and which will give you the correct eigen vectors. I hope you all enjoyed this video. Thank you all. We shall see on another problem. Thank you, good luck.